Students, let us continue the second example, how to compute the rank of a matrix by using that Echelon form method. So here I took a 3 by 4 matrix, a rectangular matrix of order 3 by 4. So these are the rows, row 1, row 2, row 3. So the target is that first you check the diagonal elements are non-zeros. You observe the first one, it is non-zero element, so we can mark up a random diagonal like this and highlight the elements in first column. C1, it is C2, it is C3, it is C4. So here we should get 0, here we should get 0. So applying the elementary row operation ERO, as I told, changing row is R2. This is going to reduce, copy the same row, and row 1 is the using row, because in first column to get zeros, make use of row 1. Then what sign you must take between these two? Check the sign of first row, first element and this element, because we are changing row 2. So both are having same sign, positive sign, you take minus. If they are opposite, take plus. And the first element will be multiplied to R2 and the second element 1 to R1. Similarly, to change R3, we have to use same row 1 to change R3 using row R1. Now compare sign of this and this. Here also same. So applying these two operations for R2 and R3, the new matrix or altered matrix will be written like this. First you fill up row 1 because it is not going to change. So 2 times R2, 2 into 1, 2, minus 2, it is 0. 2 into 0, it is 0, minus 1, it is negative 1. 2 into 1, it is 2, minus 3, it is negative 1. 2 into 6, 12, minus 4, it is positive 8. Coming back to R3, 2 into 2 minus 2, it is 0. 2 into 4, it is 8. Minus 1, it is 7. 2 into 2, 4. Minus 3, it is plus 1. 2 into 3, 6. Minus 4, it is 2. So this new matrix, again you highlight the diagonal because these are non-zero entries. Now we have to make this element 0, that is under C2. Under C2 we have to make the element 7 to be 0 below this diagonal. So because we are getting 0 here, we have to make use of row 2. Using row will be R2. Using row will be R2. It is using row. Using row. Let's just have a look of this. Now R3 is going to change. Apply the element row operation as shown below. R3 is a changing row. Changing row. Same row 3 you have to copy, and using row I wrote it is 2, R2. So same procedure, what sign you need to take here? Compare the signs of the elements of this element and this element. Here negative, here positive, both are opposite. You should take plus. Then because we are making zeros below the diagonal, you have to follow top to down rule. So first element, this element without sign, and down 7 here. Now applying this operation, the matrix is going to change. Here row 1 and row 2 will be asterisk because they are not going to change. 2, 1, 3, 4, 0, negative 1, 8, 0, 1 into R3, 7, plus 7 times R2. 7 plus minus 7 becomes 0. Similarly, 1 into R3, 1 into 1, 1, plus minus 7. 1 plus minus 7, it is negative 6. Similarly, 1 into 2, 2 plus 56, 58. 58. Just mark up the diagonal. So all the elements below the diagonal are zeros. So this is your n-step process. It is called Echelon form. Echelon form of matrix A. Matrix A. So hence we can give the rank as I told you, it is number of non-zero rows. Non-zero rows in, if I write this one as A star, I write A star is equal to, here 3 non-zero rows are there, rank is 3. So like this, we need to compute the rank by using Echelon form method. In extension to this, sometimes they may ask you to find out, you find the rank of the matrix by reduced row Echelon form method. Reduced row Echelon form method. With the same example, I can continue. Rank won't be changing. Thing is that in reducing row Echelon form method, the precaution is to be taken that the diagonal elements must be 1. Above the principal diagonal elements and below the principal diagonal must be zeros. For example, the same example we can continue as an extra point there. What do you mean by row Echelon form? Here I am going to give you the information. In the same example, rank is being found. It is not going to change. RREF short form. That means reduced row Echelon form. When you say the given matrix is in RREF method form or reduced row Echelon form method, so here his thing is that we have to make this one 0. Above this diagonal 0. Here also we have to make, here we are going to get in C2, the limit is going to 0, and this is R2. R2. So it is an extension. So to get 0 here, we are going to change row 1. Same row 1. the using row will be R2. It is using row only. It won't go and change. Using row, we write R2. And same sign strategy. Compare this sign. Above diagonal we are moving. So down to top method we are going to follow. Signs are opposite. So take plus sign. So down to top, first element for this one, top element for this one. Just we need to add. It is your ERO to be applied to get 0 there. Now A becomes, here row 1 is going to change, row 2 and row 3 will be as is. So I copy the elements of row 2 and row 3 as is. Row 2, row 3. So R1 plus R2, 2 plus 0, it is 2 itself. Here we get 0, 1 plus minus 1, 3 plus minus 1, it is plus 2, 4 plus 8 is 12. Mark the diagonal. Here, row 1 and row 2 are going to change in C3. It is in column 3. Now it is the using row. R3 will be using row. R3 will be using row. So we need to apply the operations EROs. R1 is going to change. R1 using row is R3. And R2 is going to change. R2 and using row is R3. Compare the sign of this and this. They are opposite. So we get plus sign here. These two are same. Here we get minus. Down to top method. Down element is for this. Top element is for this. Similarly, down element is 6. Top element here 1. Because here we can take 2 3s, 2 1s. So this you can rewrite as 3R1 plus R3. If there is a chance to simplify the coefficients, you can divide by the common number 2. We get R1 implies 3R1 plus 1R3. Now the matrix is going to change. Row 2, row 1 and row 2 are going to change. Row 3 remains same. First row 1, 3R1 plus 1R3. 6 plus 0, it is 6. 3 times R1, 0 plus 0, it is 0. 6 minus 6, it is 0. 3 times R1, 36 plus 58. 36 plus 58. It is 4. It is 94 here. 94. What about R2? 6 times R2. 6 here 0. 6 times R2 minus 6 plus 0. It is negative 6. 6 minus 6. Minus 6 minus of minus 6. It is plus 6 0. 6 times R2 48. 48 minus 58. It is negative 10. Negative 10. Of course, row 3 is not going to change will be as it is. So this element, this element, this element, you make it as 1. So last operation, if you apply R1 is going to change. You get 1 there, 1/6 of R1. R2, negative 1/6 of R2. R3, negative 1/6 of R3. If you operate these 3 operations, here we get A doubles are right. 1, 0, 0, 94/6. That value you can compute later. 0, 1, 0, it is 10/6. 0, 0, 1, it is minus 58/6. Because diagonal elements we made equal to 1, it is, this matrix is called RREF, reduced row echelon form method. You should see that the diagonal elements must be 1, above the diagonal and below the diagonal you get zeros. So this is about echelon form method. In next video we will discuss how to compute the rank of the matrix by canonical form method or normal form method. Here we need to apply only element row operations in echelon form, but normal form, your choice. You can apply complete row operations or complete column operations or 50% row operations, 50% column operations. Normal form will consume more time than this, and when you compute normal form method, 50% if you apply row operations, you get the answer in before you are going to conclude. Next video we will discuss in detail about canonical form or normal form method. Generally a matrix is said to be normal form or canonical form if the elements contains ones and zeros. Ones and zeros. If any matrix is given to you whose elements are ones and zeros, they come under normal form or canonical form. We will discuss in next video in detail. So do share our videos. Start watching from the first video in each playlist, whatever you select there, so that you get the clarity in concepts. Regarding any doubts, you can post directly in the comment section so that I can modify the way I am going to teach here. This is about the echelon form. In part 3, next video we compute the same rank by using normal form method. Do subscribe, like and share our videos. Learning never stops. All the best.